All right, we're going to take a look at problem set number 2. We left off finishing up the 1 through 8, trying to figure out what net force or mass or acceleration is. Problem set 2 isn't going to be much different from that. The only difference is, and I hit on this from the first section, that instead of our object accelerating, let's say forwards, now what we're going to do is we're going to look at the weight of an object. So acting on the center of an object, gravity, the gravitational pull acting on an object is going to produce its weight. So acting on the center of this object, my free body diagram, I have it acting on the center right here. The mass of the object, that's not going to change no matter where you're at. That depends on how much matter you have. What will change is what planet you're on. So if you're on the Earth, the accepted gravitational pull is 9.8 meters per second squared. Now that piece of information isn't going to be thrown into 9 through 16. It's going to be something that you will be expected to know. Okay, so if you need to put that on your formula sheet, you better put that on the formula sheet or just remember it. All right, we have number 9. It says determine the weight of an object that has a mass of, so I'll put mass of 4.8 kilograms. So no matter if you're on the moon, you're on the Earth, anywhere else that you might be, you're still going to have that amount of matter, 4.8 kilograms. What you're trying to figure out is if we are on the Earth and there is a acceleration of 9.8 meters per second squared caused by gravity. Now notice I put the little g down here. It is an acceleration, but since we're talking about gravity, I'm going to put ag. Okay, we're trying to figure out the weight of this object. So I'm going to put question mark in newtons. Weight is a force, so I'm going to put the little w as a subscript. We're not going to, I know some textbooks, they put down W equals. We're not doing that. Because we're talking about a force, and specifically the force we're talking about is weight. That's why I'm going to put FW. Subscripts are a better way to write out your formulas versus creating whole new variables like W or T for tension. We're not going to do that. We're going to stick with subscripts. So our formula, we have FW equals MAG, okay, weight, gravity. So the weight of this thing, we're going to have 4.8 kilograms times gravitational pull. We put that into your calculator. Your weight for this object would be 47.04 newtons. So whatever that object would be. All right, we go to the next thing. We have a stone weighs, so we have FW equals, it is 98 Newton. It says, what is the mass of this object? All right, now, again, gravity on the Earth, this is something that you will have to memorize or write down in your formula sheet. So we're trying to figure out the mass. So that means I'd take the weight of this object divided by the gravitational pull, and we'll come up with whatever this would be. And that, you wouldn't, I know what you're thinking. Why do I have to write this out? I can do that in my head. Yeah, but not all the problems are going to be this simple. Some of them you're going to have to really write out all of the material to really have a good understanding to answer it. So we'll move on to number 11 now. Number 11, you have a mass of 20 kilograms. And I know gravity is 9.8 meters per second squared. It's acting downwards. It says, what's the weight of this? So weight equals, that's going to be mass times gravity. So, I have that in the wrong spot. So this should be down here. I'm trying to figure out what the weight is. So I'll go FW equals 20 kilograms times gravitational pull. So the weight of this object is going to be 196 newtons. You have number 12. Number 12, we have the mass of a car has 1,000 kilograms. It says, what's the weight in newtons? Well, gravity, 9.8 meter per second squared. My formula for this, mass times acceleration due to gravity. I plug in my numbers. So you have 1,000 kilograms times gravitational pull. The weight of this car is going to be 9.8. We have to 3 places. Probably be better off just putting that into the calculator to just double check it. Number 12. Yeah, all right. I for whatever reason I was thinking that was almost too easy. So you have 9,800 newtons for this. We'll go over to. Now I see what's going on. Number 12, it wasn't 1,000. That's why it looked kind of strange, because I took the 1,000 from this one, and it should be 800. So let's just change this to be 800, and we'll change this one to be 800. Now this is going to be a little better. I knew something looked a little off. So if I put that into the calculator, 7,840 newtons. All right. And in actuality, we actually did number 13 just a second ago. So mass equals 1,000 kilograms, gravity 9.8 meter per second squared, weight. All right, so I won't waste a whole bunch of time on this because we already did this a moment ago. So you have the weight of this object. You have 1,000 kilograms times 9.8 meters per second squared. So the weight of this, as we had figured out before, 9,800 newtons. We have number 14, a small weight yacht weighs 4,900 newtons. We know gravity. And we're trying to figure out what the mass of this object is in kilograms. So mass equals weight divided by gravity. So we'll have 4,900 newtons divided by your acceleration. So the mass of this yacht comes out to be 500 kilograms. It's a small yacht. We have 15. You have a mass of 8 kilograms, and this thing weighs 78.4 newtons. It says, at what rate does the weight of the mass accelerate the mass? All right, so here we're just trying to figure out the acceleration. Question mark, meter per second squared. Now, the reason why we're trying to figure out the acceleration, I'm not putting gravity down because we don't know. It didn't say that this is on the Earth. We don't know what the acceleration is. That's what we're trying to figure out. So that's why I'm not putting G in there. We're trying to figure out what is the acceleration due to gravity acting on this object. So acceleration equals, you take your weight of your object divided by the mass. So we're finding the gravitational mass of this object with that 8 kilograms. So gravitational mass, we're using the weight of the object, the mass of the object to try to figure out your acceleration due to gravity of this object or on this object. So if A equals 78.4 newtons divided by 8 kilograms, again that 8 kilograms, since we're using that would be the gravitational mass. We put this into our calculator, and we should end up with 9.8 meter per second squared. So we could say, since we worked this out, the acceleration for this would have actually been on the Earth, or maybe some other planet with the same mass as what the Earth has. Okay, we go to the last one for problem set 2. It's a 2-part question. You have a car, it has a mass of 1,200 kilograms. What is the weight of the car? So I'm going to have gravity for this part. So our weight of this object, that's the first one. So we have weight equals mass times gravity. FW 1,200 kilograms times 9.8 meter per second squared. Your weight of this car is going to get you 11,760 newtons. And then for part B, I'm going to change the color so that way we can see it better. For part B, it says, disregarding friction, what force must the car motor apply to accelerate the car on a level highway at a rate of, all right, so this acceleration, I'm going to put like an applied force is going to be 4 meter per second squared. See, the first one, gravity, this acceleration is acting downwards, but this acceleration would be acting forwards. So we have 2 different directions. You're going to have 2 different forces that are going to be acting on this object. So I'm going to put F, applied force, equals the mass, 1,200 kilograms times our 4 meter per second squared. So the applied force that's going to be necessary to move this 1,200 kilogram car forwards along the highway at an acceleration of 4 meter per second squared is going to be 4,800 newtons worth of force. Okay. This takes care of problem set number 2, and we'll move on to problem set 3 in a little bit.